Welcome to Fresh Takes on Tech. We're continuing our season on AI in the ag sector. Today, I'm joined by Dr. Brian Lutz, Vice President of Agriculture Solutions at Corteva Agriscience. Brian leads the integration of advanced computational tools, AI, machine learning, and predictive biology into Corteva's R&D pipeline. With a background spanning biochemistry, data-driven agriculture, and leadership roles at companies like Bayer and the Climate Corporation, Brian is now focused on accelerating crop protection, innovation, and breeding at Corteva through digital modeling, in silico screening, and generative design. We'll talk about how AI is being used not just to speed up discovery, but to make it smarter and more targeted, and what that means for the future of farming. Welcome, Brian. Great to have you.
Thanks for having me, Vonnie.
Yeah, I'm really excited about this discussion because I've heard from other people in the organization and about the excitement around this, and to get to talk to the guy that's kind of spearheading it. It's really a great opportunity. So thank you.
I appreciate being here. Yeah.
So you talk about replacing randomness with prediction. How accurate are these predictions really? And what's the most surprising finding you've seen from the models so far?
First, here at Corteva, we're applying AI in a lot of different ways across really our whole value chain. So that starts all the way back at the earliest parts of research and development when we're developing new seed and crop protection products, through manufacturing and production, and then ultimately the last mile out to the customer as well. When we think about the R&D process specifically and discovery, we're really focused on how do we find better genetics, how do we identify molecules that are going to have better crop protection attributes. And historically, this has been largely a game of chance. So when we're developing new seed products, we cross two parent seeds together. We rely on genetic recombination to make new seedlings. And then we screen through all of those seedlings in hopes to find genetics that outperform the existing genetics that we have in the portfolio. Same thing with crop protection molecules. We will screen thousands or tens of thousands or hundreds of thousands of molecules in hopes of finding ones that have better attributes than the current crop protection molecules. And so really both of these processes have historically been games of chance, focused mostly on screening and selection. And so what AI is letting us do is transition from screening and selection to more prediction. In many cases, the predictions from the models aren't leading to, well, here's just the answer. But what it really does is it increases the probabilities that we're able to find new genetic recombinants and new molecules that have better attributes. The reason that's important is because these are just really, really vast spaces. And so for us to be able to wade through all of the potential possibilities with just screening and selection alone, we would never find the types of hits that we can find now with AI-enabled discovery.
So what parts of the pipeline have been kind of the hardest to automate with AI? We're in this interesting time of everyone's starting to use AI and we kind of throw it at everything. But are there areas that it's been hardest to use AI? And where does the technology still need people to be very involved in the process of R&D?
We really have humans in the loop in most of the places where we're applying AI across the value chain. Some of the areas where we've seen the most progress have been things like the labs and greenhouses where, we're under controlled environments. We can deploy a lot of automation, a lot of intensive data collection. For things like crop protection, when, we have to go out to the field, that's probably where still some of the largest opportunities are. From a crop protection standpoint, it's a little bit different than when we're doing seed development in the field. For seed, we can a lot of times centralize much of our testing footprint. And when we can centralize, then we can invest in more infrastructure, more automation, more intensive data collection. With crop protection, because a lot of times we're going out to where we have specific pests or pathogens that we're trying to provide better control. Of course, you don't want to just move those things around the landscape and introduce them somewhere else. So we don't centralize as much. So because of that, we often have to go to where the problems are. And that means that it's a little bit harder to take the robotics, the IoT, the sensors out to those locations and monitor them with the same intensity that we do when we're able to do more centralization.
What do you see? How do you think that will change, like over the next 5 years? What innovations will happen that maybe you can cut that down a little bit as far as going out in many different fields?
Yeah, it's good. I mean, it is getting a lot easier, right? So we do invest more in mobile technologies in our drone fleets. We have a very large fleet of drones that can do imaging and high intensity data collection, but even taking other types of sensors out and being able to monitor sites that are distributed all around the globe in some remote locations, even things like Starlink and having satellite connectivity, because in a lot of these areas we've historically had trouble transferring data around. So we are seeing advances where we're able to collect the types of data from even these distributed locations, where once we're able to collect the data, we can also bring a lot more of the AI and analytics to those uh, problems as well.
Let's talk a little bit about discovery. So you're using AI to reduce the 11-year plus or minus time frame for molecule discovery. Give me a specific example. What did the model suggest that a human scientist wouldn't have seen?
So as I mentioned, when you think about crop protection discovery, so this is just a really complex space. So the number that's often thrown out there is that if you look at all of the potentially bioactive molecules that exist, it's something on the order of 10 to the 60th, right? So that's a number that's extremely hard to get your head around.
Exactly.
The comparison I often give is, there's only about 10 to the 18th grains of sand on the earth. So this is many, many orders of magnitude more than the number of grains of sand on Earth. Historically, when we find a new crop protection molecule, it'd be kind of like finding a grain of sand on a beach and saying, oh, this has got the properties or the activity that we want. So when we look for the next one, we oftentimes look pretty close to where we found the first one, because we hope there are more around it with other similar beneficial properties. But just, you can imagine how hard that is, and then how much space that we just have never gotten to even explore. When we can move from the selection and screening process in the lab, where we've got to test everything empirically, to being able to move a lot of these predictions in silico using AI models and computers, now that lets us explore a much broader space. And so, a good example that we've recently been working on is we've actually, working with one of our partners, have taken some AI models that are developed for the pharma industry, because they're trying to do
Sense.
very similar research to what we do in crop protection. They're just trying to find molecules that can serve as drugs for humans. We're just trying to find molecules that can control pests and pathogens. But we've taken some of the pharma AI models, and we retrain them with our ag data. And then we ask the model, hey, can you point us to parts of the chemical universe that we haven't been working in? So areas that are very different than we've normally been searching. And the model actually didn't just give us one or two potential leads, it gave us a couple of dozen. And right now we're in the process of testing those in the lab to see, how well did the model do. We get the results back that we're hoping for. And this really changes the way that we think about discovery, because again, it can enable us to look in places that we've just never looked before.
And so that beginning part of the funnel that was just so big that you could never bring everything through it, you just made that funnel a little bit smaller and found things that you just didn't even know were there before.
That's right. And back to the point that you made, I mean, we're still talking about over a decade for us to be able to identify a new molecule and get it all the way through the pipeline and then out to a customer. Much of the pipeline, of course, is still heavily driven by regulatory timelines, because we have to go through all of the registration processes for new molecules. Those parts we aren't really able to speed up directly with AI. But where we are able to have the impact with AI is on the beginning part of the funnel, right? Because the more of the chemical space that we can search through to find those really high value targets and make those bets sooner, those are the ones that we then anchor on and see through the rest of the pipeline. So really our ultimate goal is to increase the speed and the impact of the discovery part of the funnel, but then we still have to go through all of the development process.
So talk a little bit about AI and breeding. What are you able to do in breeding that you couldn't do before AI, and where do you see future gains in breeding as well?
The breeding space, right? It's different than the crop protection or molecule space, in that we're dealing with biology and genomes, rather than just molecular interactions. But where it shares similarity is in its complexity, right? So, for example, a corn genome has almost 2.5 billion base pairs. And really, when we're talking about new seed development, it's how can we cross parent seeds to be able to get new genetic recombinants that have those superior properties. And again, historically, we've done this by breeding, which relies on sexual genetic recombination. So we have relatively limited control over how the genes are associated in the offspring. But now with gene editing, of course, we can go in and we can actually drive very intentionally where is the genetic recombination? What are the recombinants that we want to create? But when you have 2.5 billion base pairs, it starts to make the editing process itself look easy because now the hard part becomes, well, what are the recombinants that you choose to make? Just very much like AI models are helping us sort through the chemical universe in hopes of finding more efficacious crop protection molecules. Similar AI models are letting us answer the question of, well, what parts of the genome should we drive more diversity and more recombination so that we can get to those new seedling recombinants that we believe are going to have superior performance faster.
So let's talk a little bit about just in these two different areas. This is what, when I worked for Legacy DuPont and just being around Corteva, that you guys are so strong in both of these different areas of crop protection and breeding. And it's very different skill sets. It's very different products. The customer is the same and the plant is the same, but there's a huge difference between the two. So when you think about how to train the researchers to use these tools, every organization that I've talked to on this season of the podcast, like everyone's trying to figure out how do we train, how do we retool, how do we make sure that everyone is keeping up with these new tools and using it? How are you training your agronomists and researchers to work with the tools? And how's that going?
It's been pretty remarkable if you look at just the last few years at how fast a lot of the AI capabilities have advanced from just a technology perspective. And increasingly, it does feel like, the rate limiter is increasingly not necessarily the technology, but how fast can you apply the technology? How fast can you drive the training and the change management within the organization? I think of this in a couple of ways for organizations that are, I think, effective in pivoting what they do to take full advantage of AI. It requires a few things. One is it requires some really clear direction and targets to be set. Right now, I think that there's been so much sort of enthusiasm and to some degree hype around AI that what some organizations I think are doing are just sort of dropping AI tools on their employees and their researchers and saying, well, figure out how to use these things. Well, I think we can have some interesting POCs. It's hard to actually have meaningful change when you're just sort of horizontally or, not very deeply integrating these tools into your organization. So you've got to set really clear targets and objectives of what you're trying to change. Our examples like around new molecule discovery and crop protection or driving gene edited breeding, these are things that they have multiple layers to them, and AI can be applied in multiple ways as we're trying to transform those processes. I think that will drive much more meaningful change. So you've got to be clear with the organization on what you're trying to accomplish. Once you do that, then you need to make sure that you can sort of foster an innovation culture around using these tools. So figure out who are your change leaders that are really excited about the technology, but also have a lot of expertise in the domain, right? So in things like breeding and chemical discovery, you need to have teams that know both the domain, but also the excitement around the technology and sort of give them the freedom then to say, okay, well, here's what we're trying to accomplish. How are you going to bridge this gap between the way we used to do it and the way that we need to do it moving forward with more AI acceleration? And then once you can get established in that way, to use that sort of the early adopter or the folks working at the frontier to drive the change further into the organization. So really use the folks that have been serving as the champions as sort of the change catalysts also within the organization.
Here's an area where there's so much data that I can't figure out what to do with it, and I'd like to use an AI tool for that. Are there tools off the shelf that are built for breeding, or do they go find some tool that just manages that type of data and apply it to what they're doing? Does that make sense as a question?
It does, yeah. I mean, and I think what you're getting at is the whole idea of to what extent can you leverage out of the box AI
Yeah.
solutions versus, how much do you have to be able to customize AI models or tools to be able to accelerate whatever type of work you're trying to accomplish, whether that's, breeding, whether it's crop protection discovery, if it's a manufacturing process, customer engagement, et cetera. I think that where we're at right now, the most successful companies are going to be the ones that not only figure out how to develop new AI models de novo or for their own use cases, but also can leverage many of the foundational models or just other AI models, but apply them to their needs. Within Corteva, we have hundreds of AI models that are in production.
Hmm.
Some of them we have built from the ground up ourselves, and some of them are really adaptations of open source models, but just applied to a problem that we're trying to solve. All of those are very valid, right?
Hmm.
So it's more of a how can you move quickly? How can you adopt the technology? How can you apply it to a specific problem, really meets your needs. I do hear some folks say, well, maybe we don't really want to use some of the more commoditized or open source solutions. We want to try to either fine tune, retrain, or build our own models. And then I hear it the other way around, right? I really think that most need to have an open mind and say it's more of an all of the above because there's a lot of opportunity on both ends of the spectrum.
It's fascinating at this time. And I think one thing that you said that I've seen in organizations that are successful at adopting AI is finding a champion and then giving them space, giving them room to learn, giving them room to fail, because nobody knows. So it's really an interesting time that you just give people some time to mess around with something, and it may not work the first time. And the other part of it is all these tools are evolving so quickly that you might try it this week and it didn't work, and then you try it like in a month and suddenly it works. And so
Yeah.
it's moving
It
slow.
it's all about the guardrails, and it's a balancing act that takes pretty careful monitoring. But if you're too prescriptive in how to use the tools, you're certainly going to limit your opportunity to innovate and maybe find some of the most high impact opportunities. But if you're too unconstrained, again, you're kind of allowing a lot of these AI tools to be used for maybe any purpose or to any use case, and then you kind of have death by too many POCs. And we're increasingly
Yeah.
seeing in a lot of articles where companies say that they have all these AI use cases or POCs taking place, but they're not really seeing much impact on their business or much progress being made. And I think it's because they've allowed themselves to maybe get spread a little bit too thin. So it's this balancing act between, being really clear on what we're trying to accomplish and where the high impact opportunities are, but also allowing enough freedom to test and iterate and experiment within some guardrails.
So how do you benchmark model performance and kind of your equivalent of model accuracy when it comes to the outcome, when the outcome is in the crop in the field? Like when you get to that point, how do you benchmark?
And especially as we think about all of the different ways that AI is being deployed in businesses today. When we think about model performance and benchmarking, these can mean extremely different things
Hmm.
depending on the application. I'll give one example where, and we read about this all the time in the news, where a company has developed a AI agent or chatbot that is maybe customer facing, and they're worried with or have experienced challenges where maybe that agent has hallucinated or given poor output or recommendations, but that goes directly to their customer and there's not a human in the loop. And so then you've got to manage, all the consequences of that. So there's this whole area where everyone's been focused on AI model performance because of those types of use cases. But then there's maybe the other end of the spectrum where these models are being deployed in very highly controlled research contexts, like within our R&D pipeline. And there we have the benefit of simply empirically testing everything, right? So the models might give us a recommendation of a new crop protection molecule. Well, we just take it to the lab and test it. And so if it works, great. And if it doesn't, no harm, right? We move on to the next thing. So the context under which you're developing the AI solution really matters. And sometimes people blur the lines between these different use cases. But I would say no matter what, you've got to think about what are the consequences of model misbehavior or lack of model performance. and make sure that under any circumstance that you're applying, that you are able to control or respond to if a model gives you a bad recommendation. But it can be very different depending on the use case.
Let's talk a little bit about data. So, how are you validating the quality of your data across regions and crops? And are there gaps due to underrepresented geographies or crop types?
I mean, data strategy is, it's absolutely essential for AI. You can't have an AI strategy if you don't have a clear data strategy. And especially within large companies like Corteva, we collect a ton of data. I mean, we measure our data assets in the tens of petabytes, which is more than most companies out there, and not just in the ag space, but across sectors might have a couple of petabytes of data. We have tens of petabytes of data. So we have just a massive amount of data that comes in large part because of things like sequencing and phenotyping. These are just very data intensive activities. We've undergone a shift over the last couple of years in really changing our data culture. So we used to be very application centric in thinking about our data. So, in other words, we would collect data, it would come in through various data feeds. We would have an ecosystem of applications that would just analyze the data and provide whatever result was needed for a certain process. So, like a yield prediction for our breeders. We've been making a transition, though, to thinking of data as a product. So, not just data to feed an application, but that data unto itself is a product, and data is going to have multiple uses over time. By making that shift, then we're able to establish much clearer governance and roles around data. So, we've created what we call data domain owners, where they're responsible for the data assets they collect. We've created an infrastructure so that data domain owners can register their data so that we can see data across the company. We know who originated the data. It's really driving federated ownership across then all of our functions so that rather than a centralized data team, when you build this into your culture and when you build it into your roles and responsibilities, you can really raise the quality of data across every function in the company. That's what unlocks a lot of opportunity then to move very quickly with AI solutions.
That's amazing because what the biggest thing you hear people talk about is data silos, and a company as big as yours, that I can see that can happen very quickly, and so that you have this overlying. I mean, you've structured out data through structure. You've gotten rid of the data silos, which is that's quite. When did that start? When did you start having conversations about let's not have data silos and different people hiding data over in parts of the organization?
It's been a multi-year journey so far, and to be honest, in large companies, that's data strategy is oftentimes as hard or harder than your AI strategy.
Yeah.
And so in large companies, it's something that is never one and done. You don't just roll this out and expect that, okay, now we have a new way of operating. It takes a while to go down that change journey, but it's also something that you just constantly have to be promoting and elevating to sustain it. But when you do, having a good data strategy, that's what is the most transformative part of the overall AI journey.
Yeah. Well, one last question. You've touched on a number of things about how it's worked in Corteva and how you've gotten people to adopt AI as far as giving them space, giving them tools, ability to fail at things, and some guardrails. Is there anything else as you think about our other R&D companies that maybe not as big as Corteva, not have as many resources, but what kind of advice would you give for people to jump in and really start using these tools?
A couple of things. One is you just got to try, right? You do have to set some objectives and go out and have a bias towards action and just test and see what you can do. I do think we're at a really interesting time because of AI where especially a lot of these large foundation models have been trained on so much data. For example, we see benefits of these models where they've been primarily trained for pharma data. Now we can take a lot of that and fine tune the model and apply it to our ag use cases. So it's sort of democratizing a lot of there used to be silos across all of these industry segments, but because these models are able to integrate a lot of that information, we see a lot of the walls coming down even across the industry segments that have historically operated very differently. So I think regardless of company size, regardless of really what your specific focus is, there are a lot of ways to adapt many of the foundation models that are out there for a variety of use cases that can accelerate many different objectives. So I think it's just a matter of thinking carefully about what it is that you're trying to accomplish, looking for the tools that are available out there, and then just really trying to see what you can accomplish.
Well, thank you so much for your time and thanks for your work. And I learned a lot in this conversation. I haven't worked for a large company and since kind of this whole revolution started. So it's really fascinating to hear the attention you have to pay to all the different parts, to make this work. And Corteva's definitely done that. So thank you.
Well, thanks for having me, Vonnie.